topic to be discussed in this video is find the inverse cosine Fourier transform of 1 by 1 plus p square. Solution. F of x inverse Fourier transform formula is f of x is equal to 2 by pi integral 0 to infinity FCFP cos px into dp. Given FCFP is 1 by 1 plus p square, that is equal to 2 by pi integral 0 to infinity 1 by 1 plus p square cos px into dp. This is the f of x. Differentiating above equation with respect to x. d of f of x by dx is equal to 2 by pi integral 0 to infinity 1 by 1 plus p square d by dx of cos px into dp. Here that is equal to 2 by pi integral 0 to infinity 1 by 1 plus p square. Differentiation of cos px is minus sin px. Differentiation of px is with respect to x is that is p into dp. Here minus 2 by pi integral 0 to infinity p by 1 plus p square sin px into dp. Numerator and the denominator is multiplied with p, here p. That is equal to minus 2 by pi integral 0 to infinity p square sin px by 1 plus p square into p dp. Minus 2 by pi integral 0 to infinity add plus 1 and minus 1 into sin px by 1 plus p square into dp. That is minus 2 by pi integral 0 to infinity p square plus 1 by p square plus 1 into sin px dp minus integral 0 to infinity 1 by 1 plus p square here p here p is there into sin px dp. That is equal to minus 2 by pi integral 0 to infinity sin px by p into dp minus 0 to infinity sin px 1 plus p square into p into dt. That is equal to minus 2 by pi integral 0 to infinity sin px by p dp is pi by 2 minus integral 0 to infinity sin px by p into 1 plus p square into dp. That is equal to minus 2 by pi into pi by 2 minus into minus plus 2 by pi integral 0 to infinity sin px by d into d. This value is df of x by x dx is equal to minus 1 plus 2 by pi integral 0 to infinity sin px by p into 1 plus p square dt. Again, differentiate above equation with respect to x. Above equation respect to x is that is d square f of x by dx square. Constant differentiation is 0. 2 by pi integral 0 to infinity 1 by p into 1 plus p square d by dx of sin dx into dp. That is equal to 2 by pi integral 0 to infinity 1 by p into 1 plus p square. Differentiation of sin px is cos px. Px differentiation is p into this one is dx, not dp here. This one is a dx. This one is dx. This one is a dx. This is dp, not dx. dp. This one is dp. 2 by pi integral 0 to infinity pi cancel. Cos px cos px by 1 plus p square into dp. This one is f of x. This one is the entire term is f of x. D square f of x by dx square minus f of x is equal to 0. Let d is equal to d by dx. D square f of x minus f of x is equal to 0. D square minus 1 into f of x is equal to 0. That is d is equal to plus or minus 1. D is equal to plus or minus 1. Therefore, solution is solution f of x is equal to c1. Consider plus 1 e power 1 into x Second one C2 into e power minus x. This is the f of x. We know that f of x is equal to 2 by pi integral 0 to infinity 1 by 1 plus p square cos px into dp. 2 by pi integral 0 to infinity 1 by 1 plus p square cos px dp is equal to c1 e power x plus c2 into e power minus x. Let x is equal to 0. X is equal to 0 means class 0. Class 0 is 1. 2 by pi 0 to infinity 1 by 1 plus p square into dp is equal to c1 e power 0 is 1. C2 e power minus 0 is also 1. C1 plus C2. 2 by pi 1 by a tan inverse p by a. You see the 1 by 1 plus p square dp is 1 by 1 tan inverse p by 1 0 to infinity is equal to C1 plus C2. That is equal to 2 by pi tan inverse infinity is pi by 2 is equal to C1 plus C2. When x is equal to 0, C1 plus C2 is equal to 1. C1 plus C2 is equal to 1. Consider d square, consider d square I by dx square, d square f of x by from d f of x by dx is equal to minus 1 plus 2 by pi integral 0 to infinity 1 by p sin px by 1 plus p square into dp. But solution is f of x is equal to c1 e power x plus c2 into e power minus x. D by f of x by dx is equal to c1 e power x minus c2 into e power x. Substitute the df of x by dx is equal to c1 e power x minus c2 into e power minus x is equal to minus 1 plus 2 by pi integral 0 to infinity 1 by p sin px by 1 plus p square into dp. When x is equal to 0, substitute x is equal to 0. C1 minus C2 e power 0 is 1, e power minus 0 is also 1, equal minus 1. 2 by pi, the entire term value is 0 and x is equal to 0. C1, therefore C1 plus C2 is equal to 1, C1 minus C2 is equal to minus 1. We add these two. 2c1 is equal to 1 minus 1, that is equal to 0. Therefore, c1 is equal to 0. C1 is equal to 0. Substitute C1 plus C2 is equal to 1. C1 is equal to 0. C2 is equal to 1. Therefore, the solution of that one is f of x is equal to C1 e power x, not x. C1 is equal to 0, 0 into e power x. C2 is equal to 1. Therefore, f of x is equal to e power minus x. If you apply Fourier cosine Fourier transform of this function, we will get 1 by Fourier cosine transform of f of x. This function is 1 by 1 plus e square. This is the solution. If you like this video, please subscribe to the channel for further updates. Thank you.